Hi everybody, I'm going to record a tutorial for you about how to install the Keil tools on your home machines. This is on an iMac, so it has Parallels running. As you see on the bottom right here, I have a Parallels desktop, and this window is basically a Windows 7 machine. And you'll see that I have the web browser up, and I've gotten to a place where I can download the exe. Now you'll notice I have the exe file here and I've already downloaded it. But let me go back and just walk you through how you would get to a place where you get to the exe to install the tools. So I'll go back, I'll go back on the web browser. Okay, and I got here by just searching in Google for Keil tools. And you'll notice I went to Keil Embedded Development Tools, just the main website. And then I clicked on Product Downloads. And when I clicked on Product Downloads, it went to this screen where I had four choices. MDK ARM is the choice you want. And there's some other ones that aren't relevant for our purposes. So MDK ARM is what we click on. And then once we do that, it'll ask us for information. However, once you put in all your information, you can put in your own information. Once you do that, you click on the submit button and it'll go to that screen we saw at the very beginning, which was the screen that had the exe file. So I can't do that again. Apparently there's a block on their website to actually resubmit this form because I just did already. But anyway, once you submit this form, as we kind of walk through how to get here, once you submit that form, then you'll be it'll have that exe file right in the middle of the page, and you just click on it and download it. Okay, so now we downloaded it, and just a side note, I'm running Parallels on the iMac, as I mentioned before, and I'm running Windows 7 32-bit because the Keil tools run on a 32-bit machine. They don't run on or they have some problems at least running on a 64-bit machine. So if you buy Windows 7 from the Campus Computer Corner, then you buy the Windows 7 with that's 32-bit. Okay, so once you install Parallels, then you can install Windows 7 in the virtual machine, and then you can get to a place where you can download this exe file. And you know, if you just have a PC, you can just go open up your web browser and Google Keil tools and do everything we just said. So now we're at a place where everybody has the exe file, and let's open up the exe file and walk through the process of installing. So I'm saying yes, I'm going to install it even though I downloaded it, and it will you'll agree to the licensing, and then I can pick my location of Keil, C:\Keil, that's fine. And then I can put in my information the same as what I put in before, though I don't think they'll check, but just in case. And then I get to a point where it's actually installing. So once we've installed, then we can, I'll just leave this over here running and I can talk about something else for a second. Once you install, you can go into Blackboard and you can download these .s files. Those are the assembly files that you will be using in class. So you noticed last time we had this load, store, and addressing, and I had this file called littleindian.s. And that's the assembly file we'll add to the project once we create a new project. This is a constants.s and addresses.s that we'll be talking about today in class. And then I'll have another assembly file for the logic and arithmetic. So once we have this installed, we'll be able to create a project on Keil, and then we'll be able to run some simple installations. So as mentioned in class, the Appendix B in this book goes through all the steps that we have to install the tools. Well, I guess it assumes that you're able to go to the website and get the tools, but we just went and did that ourselves, and so you should be able to simulate the, or I'm sorry, you should be able to download the ARM tools with the same method we just did. So then once you're there, you can go to Appendix B and run through that. But so that we have the complete tour, let's go ahead and complete this. We'll just do simulated hardware. Eventually you can get to your board, your exact board. There's some Samsung boards on here and Keil boards. But for now, let's just do simulated hardware because this is your home machine and you're not connecting up to hardware directly. We can go ahead and finish this. And we'll install the U-Link. Okay, so now this created a Keil UVision 4, and so let's go ahead and open that up. It has these sample C files, but let's go ahead and close this project, and I'll walk you through how to open up a new project. So let's say a project, new UVision project, and wherever you want to set this up, let's go ahead and put my documents. Let's just say sample project, and to go ahead and save that in my documents, and then it'll ask you which device you want to target, and this is where you can do ARM7 as we've been talking about with Little Indian. And this ARM7 TDMI is what our book is based upon. So we'll do that. And say OK. And then it'll still show our project, but we don't have anything in our project right now. So what we want to do is create a new file. And in fact, what we could do is we could just find this addresses.s and attach and add this to the project directly. But so that you know how to add your own file, we can do it another way. And let's say I want to just say simple project like area sample program code read only, and then I just put in entry. That's where it knows how to start my code. And then let's just say move R0, we're going to have the value 5, and then comment that says initialize R0. And then let's go ahead and end the program. Okay, so we're gonna save the program. So file, save, and it'll ask you what you want to save it. And the key thing here is that you have a name that ends in .s. So you say sample program.s, and that .s is going to let it know that it's an assembly file. So you'll see immediately once it saves it as .s, then it'll pick up that it's a assembly file, and it'll say I recognize these directives and these instructions. Okay, so then let's say we want to add this to the project. So we do control click or right click on the source group, and on Mac it's control shift and add files to the source group. And let's try to find that. Let's see, documents. Oh, we need it to be the .s files as we named it, and there it is, sample program.s. And so now we've added that, so we can close that out. We've added this sample program to our group. And what we can do is we can build this file. And we have 0 errors, 0 warnings. And then we can go into the debugger, which is this red D. So that other icon we did was a build or rebuild. So you can do build, but generally I just do rebuild every time because you might make some modification and then you go back to rebuild. But if you do rebuild and it's never built before, it's just a build. So then after we've built it, then we're able to start and stop the debug session, or start the debug session. And again, this is an evaluation piece of code. We just downloaded it from the internet, and so we can have a max code size of 32 kilobytes, which should be okay for all of our homeworks and all of your labs up until the project, and maybe even the project. So let's say okay. It'll take us to the debugger. Let's open this up, and we'll see here that we have this one line of code, which is, it has the assembly here, which is move R05 and initialize R0 as our comment. And then there's the actual instruction. Those are the 32 bits that represent this instruction. And we haven't done anything yet. So it still has R0 as 0 because it initializes everything to 0. And so then let's just step over this move instruction and watch R0 change to 5. Now if we say, oh, I want to run that program again, we can just say reset the program. It'll clear out all the registers and it'll go back to the entry point, which is where the move 5 is. Alright, so let's go back. Just one other thing to do. Let's say we don't want this sample program.s in our group anymore. So let's try to remove that. Remove sample program.s. Yes, we're sure. Okay, and then let's add the file, which is the assembly program that we downloaded from the Chrome tool. So let's see if we can find that. My downloads maybe. Let's see if it's in there. Okay, there it is. Addresses.s we downloaded. So it should be in your downloads folder if you use Chrome, and then we'll add that as our program that we want to look at. So let's click on that and see what it is. So this is one of the programs we'll be doing today. You can do it with any one of those assembly programs that you have on Blackboard. But basically, we just added this to our project. And so now we can build it again, and it says a warning, but no errors. And the warning is this move PCLR. It wants us to use this instruction, which is preferred, which is BX, which is basically a return from a branch. So it's just an instruction. So it's a recommendation. Now the book says to set up the global reset handler and all that, but that's only if you're dealing with hardware. We're not dealing with hardware, we're just using the simulation tool right now, so we can remove this reset handler out of our code. Save it. It would have compiled the other way, would have assembled the other way, so I'll just prove that to you. We did build that way, and then we changed it, and then take it out, and we can just have area starting, just like we did in our first example, and it still works. So we do rebuild, and it still works, and then we can go into the debugger. Okay, and so here's our program again, and we can go through it as we'll do in class today. But you can see one thing I did want you to notice is that if you did the step over instead of the step into. Some machines call this step into, but they call it step. The step over will actually won't take this branch and link. It'll just run the whole subroutine and then return and then go to the next thing. But if you step into, the branch will be taken and you'll go into the first instruction of the subroutine. So let's start it again and do a branch over instead of that. So if we did a branch over, it would run all of that code, but it would return back. So instead of just stepping into, which is the next instruction after the branch, it would step over, meaning it would run all of these instructions up through the return, and then it would take the program counter to the next instruction. Okay, so again, step into goes into the first instruction of the subroutine. Step over would run the whole subroutine. All right, so then you can play with the tools now, and hopefully you guys will be using this for your homeworks and getting perfect grades on your homeworks. All right, see you in lecture. Bye.